So, hello everyone, I'm Milad Kambari, and I welcome you to the first video of this course, The Foundation to Hard Surface Modeling. I want to first explain what actually is considered a hard surface, start by simple examples, and move towards some complex ones. So, hard surface, what does it mean, right? It's not actually hard to explain and hard thing to understand. It's like most industrial props, designs, objects that you see around are, in fact, hard surface structures. Let me show you with concrete images. So, I have searched for hard surface models in Pinterest, and as you can clearly see, it's like we can label almost every industrial piece and model as hard surface. And I will start with some really simple models and examples here, and then we'll move towards some harder and more complex examples in the other videos. In 3ds Max, I add a plane, and let us begin. Our first step is to clarify and find out how TurboSmooth works, because it's a very important concept in hard surface modeling. We must have clear understanding of how it works. In regular box modeling, though, at times we might get what we want without using TurboSmooth, but here it plays a very important role. By knowing how TurboSmooth works and its behaviors with the techniques we're going to learn here, we'll be able to model absolutely, or almost better say, anything we want. But before we get into everything we want to learn in this course, we should pay attention to do something first that helps us significantly in our process, and that's adding proper material to our mesh. It's going to be a dark, standard material with proper specular level and glossiness. You might ask, why in a standard material, right? Because first, it's easy to control its attributes, and then it doesn't need to be rendered, and it's going to be directly visible and functioning in the viewport. I apply it to our plane here, and now look. See how our mesh now reacts to the light, and it's no longer just a solid color. This helps us easily identify the problems that our mesh might have from the inside. We might run into some issues like artifacts and distortions that are caused by maybe our lack of TurboSmooth knowledge, or lack of topology understanding, or some extra vertices. But this way, they're going to be easily found using this type of material. Let's start with our plane that has no segments. I will give it Edit Poly modifier. I will convert it to Edit Poly and extrude this edge. So what TurboSmooth does to our mesh here is to soften the edge we have in between and make it as it's a curve and as it's a fillet. But you may say, how then to control this curve, right? I say by simply adding more edges. This way, we can limit the behavior of TurboSmooth and the curvature. I select this edge here and give it chamfer modifier to simply have 2 edges instead of 1. Pay attention to the shading and curvature that's being limited on the second model. The edges that we use to limit this curvature and preserve the shape that we want is called supportive edges. Now I get another copy of this. I'll show you. As you see here in the last example, we still get a fillet effect. Let me increase the number to show you better. But if we add more edges here, we can preserve our chamfer effect. See, our chamfer is well preserved. Now I create another plane, apply it our material, convert it to Edit Poly, extrude the edges down, and leave it be just like that. I don't want to fill the bottom surface down there. I apply Turbo Smooth, and as we can see, the same thing has happened here. We have a curvature looking like a dome. But why isn't the bottom part changed? Why is it standing still? Do you remember the first model? That it was about the edge in between that created the base for our operation? That then we limited it even more later? Here is a point. This curvature is created only when we have two edges connected to each other like this. So we don't get distortion or any curvature in this bottom part right here. Now to continue, I want to further limit the curve we get here. In the previous operations, we used extrude and chamfer, but here we can do other things to add an edge loop across our model. We can either select this edge and then press ring select, then connect to get a new supportive edge and move it up, or we can do completely another thing. We have something in here in the edit menu that's named Swift Loop. This way we can create an edge loop just in seconds. If you see here, that dome has now turned to something like a cylinder. Now I'll continue adding more loops. What do we have here now? By adding more supportive edges, we have now preserved our original shape here. Just like before, this is now the second model we had earlier. When we got the fillet effect, we can get chamfer effect again by dissolving the edges between, by clicking on the edge twice, and then add the supportive edges to our main defining shape to preserve the chamfer effect. This way, Turbo Smooth sees nothing extra to make the curve out of. I dissolve this by pressing Ctrl and hit Delete. Now I'm going to add even more supportive edge loops. And now, I think now we get the shading that we want. Let's go to the other example. Again, I create a plane, and again, I apply the material. Now, I want to extrude two faces separately to create a gap in between. With this gap here, if we apply Turbo Smooth, we get something like this, but we still have the gap. So, we should first select the two edges and fill by bridge. Now we have our complete curvature without limitation. To limit and add supportive edges, we again select Swift Loop, but look, as you might have noticed in the last example for a second, this loop isn't working. It doesn't go across our mesh horizontally. Here's the point. For edge loops, do not go to surfaces that have less than 4 vertices. Notice how by bridging the gap, we got a triangle? Yup. To have proper edge loops, we should make sure that there's no triangles. Knowing this is very crucial to edge flow and edge direction. I now can create edge on one side, and as you can see, there's no more triangles, so it's going to be normal all over again. So now I want to adjust the angle by doing edge sliding. I'm going to select the loop and go to my side view, put the constraint on edge so that I only move my vertices and my edges on the surface of the edge and not in the air. Then I want my main face to be also limited by supportive edges. The best way to do this is to get an inset and then normalize the edges we want by selecting lines and scaling. Now, I give it turbo smooth and bear witness what we get here. This is now a curve, but why is it like this? Why does it look like this? Let's now revert turbo smooth for a second. And I'm going to zoom here a little bit. And don't you see the triangle here? Turbo smooth makes edge loops across our mesh. And edge loops do not understand triangles. So they turn around and mess our topology. That's why we should evade triangles as much as possible in the key parts of our modeling. To fix this, fortunately, we are working in such a low poly mesh, and we can actually fix it quickly by welding the two verts right here. Now I turn on the turbo smooth and there we go. Much more clear. Triangle, quad. Later, when we model industrial parts, you will see how these little verts play important roles to what they're supposed to do. Now in the next form, I want to extrude this edge for 2 times, just like this. Select these 2 edges and chamfer for 2 times. We don't need to repeat, just press chamfer all over again. This way, I want to keep the chamfer effect and get my sharp edges instead of the fillet. Now, it's sharp enough, yes, but here's another point. If we want to preserve our sharpness even more, we should know that instead of 1 edge, we should support our detail or shape with 2 edges from the both sides. Now you see, it's even sharper than before. So up until now, we had examples of how curves work in turbo smooth and how we can control the density of it. Now let's have simple detail in our model. It can be a crack, it can be a hole, or complex geometry in curves. But for now, I want to focus on the most simple forms on the get-go. Just like before, I put an edge loop by connecting the 2 edges. Do a chamfer to get another edge from it. Select the face in face select mode and extrude it down. Now I remove these 2 extra faces on the sides because we don't need them to maintain our detail. Like before, we have to chamfer the edges here for 2 consecutive times. And just like that, we have made a nice little detail. Now, if we want this detail across curvature, we make another model for demonstration. Chamfer extrude it for 2 times and we see the turbo smooth does its job, making it a curve. Now what if we want this detail across curvature? I'm gonna add another plane just for this demonstration. As I said, I want to create the previous detail now across a curved shape. I will convert my model to editable poly and extrude it for 2 times to be in the shape that we want, and let us see. I turn on the turbo smooth and I see that it's doing its job making a curve, but let me adjust the shape for further. So now let us have 2 extra edges instead of 1 here and press extrude and extrude these edges down. Later I will show you how extrusion and chamfer differ and result different shapes. Now in this situation we chamfer the edge, limiting the turbo smooth as it will reduce the curvature, and also we repeat the same thing for the outer edges and we do the same thing. Now pay attention. In our model now with these 2 details we still have a curve that manages to connect itself to our main edge. But in the previous model where we first did chamfer instead of extrusion, we got none of that. Here, it's a straight line going down. A lot of models are actually created using this method, creating a little hole. For further demonstration, I create another one here with extrusion. Only to note, remember when you want to select an edge loop, you can easily double click on the edge that you want. So I reduced the width on this one, and I also will reduce the depth on this one. And after that, I'm satisfied with the adjustments. I will chamfer the edges as before. So I was saying, when you want to just create a little hole on the surface, you can just do the extrusion instead of chamfer. But whenever you want the surface to go straight down, you need to first chamfer the main edge and then extrude it. One thing to keep in mind when you want to extrude something down in the exact orientation of the model is that you have to set the constraint to local mode to get it right. And something personal. It's most of the time when I want to put this detail on a hard surface model, I prefer to use chamfer operation instead of extrude. I feel it's like more shape defining. So I think it's enough for this session, and let us continue in the next chapter.